Good day, ECE2A, and for today's discussion, it's all about circuit analysis and network theorem. And our first topic here is the Kirchhoff's law. First and foremost, credits to the owner of this presentation. So, Kirchhoff's law was named after the German physicist Gustav Robert Kirchhoff. He contributed to the fundamental understanding of electrical circuit. Kaya nga po, meron tayong Kirchhoff's law. And this law deals with the conservation of current and energy within electrical circuits. So dito po sa unang topic natin, which is yung Kirchhoff's law, gagamitin natin siya in order to solve or analyze our circuit. So dito, gagawin natin is to first is to know yung ating theory. Second is to apply the theory in circuit problem. Without further ado, let's move to our discussion. Dito po sa Kirchhoff's law, meron tayong dalawang rules na sinusunod. Una is yung Kirchhoff's Junction Rule or mas kilala bilang KCL. Susunod is yung ating Kirchhoff's Loop Rule, which is yung KVL. So, una nating i-discuss is yung ating Kirchhoff's Junction Rule or KCL, which is yung Kirchhoff's Current Law. Mas kilala po kasi siya as Kirchhoff's Current Law. Based dito sa meaning that the current going in equals current coming out. So, para mas maintindihan natin siya, illustrate na lang natin siya. Sabi kasi dito, sa Kirchhoff's current law, that the total current entering a junction or node is equal to the charge leaving the node as no charge is lost. So, we have the node or yung junction, tinatawag natin. Yan. So, ang sabi, that the current entering, so halimbawa, I1 is entering the node. So, ito po yung node natin. Yung node, ito yung nagdudugtong sa mga branches natin. Then, syempre, upon entering this node, dito sa node na yan, mahati yung ating I1. So, magiging I2, and then we have the I3. Therefore, we can say, in a mathematical equation that I1 is equal sa I2 plus I3. Kasi nga, yung current going in ay equal lang daw po sa current coming out. So, from here, from this side of our circuit, pumunta yung ating current dito. And nag-share lang din dito. So, pumunta dito. So, nahati yung current I1 natin. Naging I2 and I3. Therefore, masasabi natin, if we combine this, I1 and I2, is equal lang din sa mismong I1 natin. Kaya the current going in equals current coming out. Sunod natin na rule is yung ating Kirchhoff's Loop Rule or mas kilala bilang KVL or Kirchhoff's Voltage Law. Ang sabi po dito that the sum of the voltage changes around a loop is 0. So the voltage around a loop equals the sum of every voltage drop in the same loop for any closed network and equals to 0. So, for example po, we have a circuit diagram na series connection. Yan, meron tayong tatlong resistors. And then, we tried to have a loop. So, pag naglo-loop tayo, it's either a clockwise direction or a counterclockwise direction. So, di ba, pag nagaano tayo ng voltage, halimbawa may apparatus tayo, anong ginagamit nating device for measuring the voltage? We have the voltmeter. So, voltmeter, halimbawa, gawa tayong voltmeter here, then another here, then another voltmeter here. And bawat endpoints dito is meron tayong mga junction. So, A, B, C, and D. So, ang sabi dito, sum ng voltage changes around a loop is 0. So, unang voltage natin is VAB plus yung voltage natin here sa second resistor natin is voltage BC plus voltage natin kay CD is equal sa 0. Ibig sabihin, summation lang ng mga voltages nito ay mag-i-equals lang din sa 0. Kaya po, yung Kirchhoff's rule, yung dalawang rule na yan, yung KCL and KVL na tinatawag, is nagpapakita ng idea or konsepto ng conservation of charges and energy. Kasi, sinasabi lang nila na, ayan nga, sa una, which is yung KCL, that the current going in equals lang sa current coming out. And also, yung sum of the voltage changes around the loop is 0. Ibig sabihin, there is no energy lost. Maliwanag po? Maliwanag. So dito, pinakita that the junction rule, so conceptual basis conservation of charge. At any junction in a circuit, the current that enters the junction equals the current that leaves the junction. So na-explain ko na nga kanina, papansinin nyo yung ating mga currents here. So we have I3 here, I2 here, and I1 here. Right? So this I2 is going this direction. Then I1 natin is going this direction. They are going to our node. And then this one, the combination of I1 and I2 is our I3. Is going here the direction. That's why yung I1 plus I2 natin is equal sa I3. So the current that enters the junction equals the current that leaves the junction. Yan lang yan. Sunod is yung ating loop rule. So the conceptual basis conservation of energy, going around any complete loop in a circuit, the sum total of all the potential differences is 0. So, the potential differences pertaining here is yung ating mga voltages. So, for example daw, meron tayong looping at this branch. And yung looping natin is counterclockwise. Counterclockwise. Pag ganyan tayo naglo-loop. So, ang gawin natin, pag naglo-loop tayo under KVL, meron tayong sinusunod na sign convention. So kapag current po, pag yung current natin, halimbawa nag-loop tayo. So ito yung loop natin, di ba? And alam natin meron tayong current flow. So ito yung current flow natin, right? Also, we have another current flow dito. And alam natin that kada resistance is meron tayong voltages drop. So, ang mangyayari po, kapag nag-loop tayo dito sa VI, start tayo dito. So, from negative, diba ito positive to? So, from negative, lumabas siya ng positive. Therefore, positive tayo kay VI. And then, diba meron tayong current? Ito, current natin, I1, dadaan siya ng R1 natin. Kapag daw po, yung current natin is along sa ating loop, yung magiging sign convention po nila, di ba yung multiply ng R1 natin and I1 is equal sa voltage, di ba? Voltage ng R1. So, mangyayari, ang sign convention po nila is negative. Kaya po meron tayong negative I1 R1 dito. So, parang V1 minus VR1. Tapos, papansinin nyo, dito sa V2 natin, positive, negative. Ibig sabihin, at this loop, pumasok ng positive. Sumunod is, lumabas siya ng negative. Kaya meron tayong negative V2. And then, meron tayo ditong I2, yung current natin. Pero, kung papansinin nyo, yung looping natin is against doon sa ating I2. Kaya, yung ating yung ating sign convention for that is positive. So we have positive VR2 is equal to 0. So kapag yung current natin, so positive tayo, kapag opposite tayo sa direksyon ng ating looping, the direction of looping kapag opposite tayo sa direction ng ating looping. Kapag yung current flow natin is opposite sa direction ng ating looping, that is positive. And negative naman kapag same way sila of the looping. Ayun yung dapat natin tandaan pagdating sa KVL. Maliwanag? So, ayun nga. So, yung sum daw po ng mga voltages, V1 minus VR1 minus V2 plus VR3 is equal to 0. Ganun po pagdating sa ating the loop rule. So, dito, pinapakita lang yung ating Kirchhoff's rule. So, ang sabi dito, yung unang step natin is to label all the currents kung saan magpo-flow yung ating current. So, dito meron tayong I1, then dito I2, then dito we have the I3, we have the I4, papunta sila daw dito sa way na to, and then we have I5 here. Then write down the junction equation. So we have the in and out. So lahat. So kung i-ano natin yan sa equation, we have here. So kung halimbawa dito sa junction na to, at this junction, that would be I1 is equal to, pababa dito, di ba? So we have I2 plus tayo. So pwede nating sabihin na, diba ito combination to, I3. So pagkalabas nila dito, if ever na ganito yung looping, yung flow ng kanilang electrons is downward. So yung combination ng I3 tsaka I4 natin is equal sa I5, diba? Dito siya sa direction na to. So we could say that this is I5. So we have I3 plus I4 is equal sa I5. So all in all, we could say that I1 is equal to I2 plus I3 plus I4. And then, sabi dito, yun yung sa write down the junction equation So, in is equal sa out. So, nag-in tayo kay 1. Bumaba ngayon dito, nahati, diba? Nag-separate way yung 1 natin. So, we have I2. Then, pumasok din dito, we have the I3 and I4. And then, lumabas ito, if ever na ganito yung kanilang flow ng electrons is pababa, punta sila dito kay I5. So, magmimit ngayon si I2 and I5. Kaya po, meron tayo ditong I1 is equal sa I2 plus I5. And alam din natin that the combination ng ating I3 and I4 is equal sa I5. Therefore, we could say that I1 is equal sa I2, I3, and I4. Yung kanilang summation. So, number 3, choose loop and direction. Choose any direction, you will need one less loop than unknown currents. So, ibig sabihin lang po dito, maglo-looping lang tayo. Kung saan gusto natin, it's either clockwise direction or kaya man counterclockwise direction. So, dito, write down all the voltage changes. Be careful about the sign. So, for example po, dito tayo mag-loop at this part. So, nag-loop po si sir at a clockwise direction. So, ano yung dadaanan natin? So, ang sabi dito, for the batteries, voltage change is positive when summing from negative to positive. So, dito nakita natin, upon looping, pumasok siya sa negative and dito lumabas sa positive. So, E1 natin is positive. And then, kapag daw po, yung ating resistor, change is negative when summing the direction of the current. Diba sabi natin, kapag alam natin na yung R1, yung mga resistors natin is merong mga voltage drops, right? Therefore, pag yung ating looping is the same way nung ating dadaanang resistor, yung current flow natin doon, so magiging ano natin is minus yung convention natin. So that is 1, I1, R1, and then punta siya dito sa R2, right? So, dadaan ulit. So, that is same way. So, that is negative I2, R2, and then, dadaan siya ng I2. So, I2 natin, ay E2 rather, sorry. That's E2. Dadaan tayo ng E2 from positive, negative. So, that is negative E2 is equal to 0. So, ganun po yung ating paglulup. Pag KVL. Kasi voltage tayo. Okay, let's have a loop rule practice. So, dito, try natin mag-looping sa loob. Yan. That's our loop 1. So, alam natin that this is, yung shorter dito sa battery natin is negative. Yung longest is yung ating positive. Dito rin. Dito. Yan. So, papansinin nyo, pag nag-loop tayo, so, start tayo dito kay battery E1. So, we have positive, gawin lang muna natin yung mga symbols. So, we have E1. So, again, kapag parehas tayo ng direction ng ating current flow, that is minus sign. So, minus I1, R1 natin. So, yung I1 natin is yung I, right? So, sunod natin is yung 10 volts. E2. E2. Kasi negative siya lalabas. And then, we have the R2. So, along ulit siya sa ating current flow. So, that is negative I2, R2 equal to 0. And alam natin, kapag nasa isang series tayo, di ba, yung current nila is just the same. And this one, I1, will be represented by I is equal sa I1 is equal sa I2. So, we can rewrite this equation by I1 is equal to, sorry, that's not equal. That's minus. So, minus I R1 minus E2 minus I R2 is equal to 0. Then, after that, meron tayong value ng E1 and E2, right? So, let's substitute yung ating mga values. So, we have 50 volts minus I R1 minus 10 volts minus I R2 is equal to 0. And then, combine like terms tayo. So, we have 50 minus 10, we got 40 volts minus I R1 minus I R2 is equal to 0. And then, we can transpose yung ating IR1 minus IR2. Kasi nga, pinapanap sa atin is yung ating I, right? So, we can able to transpose it on the right-hand side ng ating equation. So, we have 40 volts is equal to, transpose po natin to, tsaka to. So, we have I R1 plus I R2. And then, syempre, we can factor out yung ating I because that is a common factor. So, R1 natin, ano yung R1 natin? We have 5 ohms plus yung R2 natin, that is 15 ohms. So, we can add it up we got to have 20 ohms all over 20 ohms. So we can cancel this out. So I po natin is equal sa, so 40 volts all over 20 ohms, that is 2 ampere. So this is our current. So let's try to check if this value is correct. So E1 natin, that is 50, right? So balik po tayo dito sa ating to. Ayan. Substitute natin kasi may value na tayo ng ating I. So we have 50 minus, so I natin is 2 ampere multiplied by 5. So that is 10 minus ito natin, that is 10 minus yung ating R2. So 2 times 15, that is 30, is equal to 0. So 50, so 10 plus 10 plus 30, so we got negative 50 is equal to 0. So 0 is equal to 0. So tama yung nakuha nating current value, that is 2 ampere. Let's check this out. Resistors R1 tsaka R2. So ano kaling connection meron tayo sa R1 and R2? So una, is it in parallel? Number 2, is it in series? Or number 3, neither? Anyone? So the answer for this is neither. Ibig sabihin, it's not a parallel, it's not a series. Yung connection natin with the R1 and R2. Why? Because, papansinin nyo, dito sa connection na meron sa R1, sa branch R1, and dito, so we have the E2. So we cannot say that this is in a parallel connection. Kasi, sabi dito, that the definition of a parallel connection, that two elements are in parallel if and only if you can make a loop that contains only those two elements. Ibig sabihin, yung R1 lang and R2 yung ating dalawang element. And wala tayong kasamang involvement ng ating E2. Ayan, sabi dito, that the upper loop contains R1 and R2 but also yung ating E2. So dito, pre-flight 10.1. So calculating the current through resistor 1. So dito po, it is vividly or nakikita natin agad na yung looping na ginawa ng ating sa presentation natin is dito sa malaking loop siya. So ibig sabihin hindi siya nag-loop dito sa loob. Hindi siya nag-loop dito. So hindi siya nag-loop dito, hindi siya nag-loop dito. Ayan. So bali isang malaking looping yung ginawa niya pabalik dito. So from looping natin ng ganyan, so let's try to calculate, pero dito meron na tayong given na sagot. So try to loop this one. So we have negative here, we have the positive, and then KVL tayo ha. So ayan. Then yung dinaanan niya is yung I1 natin and R, which is 10 ohms. Then pabalik doon sa ating E1. So we got E1, ito yun, kasi negative, positive. So sabi ko nga, kapag same way tayo ng looping, sa same ng direction ng ating current, that is negative. So we have negative I1 here, and we have the value of R. So, ang pinapanap sa atin is yung current. So that is I1, right? So we have E1 minus I1 R is equal to 0. So for us to have here I1, lipat natin sa kabila. So we have E1 rather, sorry. So E1, so ito I1 R. So for us to get I1, so isolate natin siya. Mag-divide tayo ng R. That is E1 all over R. So E1 natin, that is 10 volts all over yung R value natin, that is 10 ohms. So we got 1 ampere. Kaya dito meron tayong sagot na 1 ampere. Dito ang tanong naman, how would I1 change? Paano daw magbabago yung I1 natin if the switch was open? So dito, naka-open yung ating switch, di ba? So, is it I1 increase? I1 natin no change? Or yung I1 natin is magdi-decrease yung kanyang value? Diba ang concept natin, kapag meron tayong switch and naka-open siya, wala tayong current flow. But kung papansinin natin yung ating connection from here, going here, still, closed circuit tayo. Therefore, masasabi natin that the I1 would not change. Would not change. Sunod natin is to calculate daw natin yung current through resistor 2. So, resistor 2 tayo. Ito. Resistor 2. So, still 10 ohm siya. Okay? Then, nag-start tayo mag-loop dito. Ayan, pa ganyan. Negative, positive. Tapos, positive dito, negative. Then, same flow. Yan. So, let's try. So, we have E1. Positive tayo lumabas. Then, minus tayo ng E2. Kasi sa negative tayo lumabas. Dito. And then, same flow tayo. So, that is minus I2 R is equal to 0. So, E1 natin, that is 10 volts. Minus tayo ng 5 volts. Siyempre, ito, lipat na natin sa kabila. We have I2, R. Tapos, alam natin yung value ng R natin. Diba? That is 10 ohms. So, that is 10 ohms. All over tayo ng 10 ohms tayo dito. Cancel, cancel. So, I2 po natin is equal sa, so, 10 minus 5, that is 5 volts all over 10 ohms. Therefore, that is 1/2 ampere or 0.5 ampere. Kaya 0.5 yung nakuha natin dito. Paliwanag po. Okay. So, sabi dito, how do I know the direction ng I2? So, ito raw. Paano daw natin malalaman yung direction niya, ng current flow niya? Is it going to the right or going to the left? Ano nga ba yung tama? Sabi dito, it doesn't matter. Choose whatever direction you like, then solve the equation to find I2. If the result is positive, then your initial guess was correct. If the result is negative, then actual direction is opposite to your initial guess. Work through pre-flight with opposite sign for I2. So, yan. Nagawa siya ng another looping. So, ganun pa rin. Positive to. And then, lumabas sa negative. So, negative I2. So, kung ito yung bago nating looping, right? Yung bagong direction ng I2 natin, right? Kung kanina, papunta siya dito. Pero ngayon, naging papunta siya sa left. So, dahil nga, naglooping tayo ng paganito, pa clockwise, so it is against our looping. Therefore, positive yung kanya naging sign convention dito. So, by solving this one, it gives us negative 0.5 ampere. So, this answer has the same magnitude as before but opposite yung ating nakuhang sign. So, meaning po nun, yung current daw natin goes to the left as we found before. So, pag nakuha lang tayo ng mga negative values na current, ibig sabihin, mali lang yung ating direction ng flow ng ating current. Kasi tayo yung nag-a-assign minsan ng mga flow ng current natin. So, if meron tayong makuhang negative value, ililipat lang natin siya or isuswitch lang natin yung ating flow para maging positive. Ayun, kanina nga nasolve na natin yung nasabi na nga natin kung ano yung Kirchhoff's junction rule. So the current entering is equal sa current leaving. So papansinin natin yung ating yung ating drawing dito. So we have the IB, nahati yung IB sa dalawa, we have the I1 and I2. Therefore masasabi natin that IB is equal to I1 plus I2. And kanina nga, nasolve na natin yung ating I1 and I2. So, yung I1 natin nakuha natin is 1 ampere. And yung ating I2 that is 0.5, right? So, therefore, yung IB po natin is equal sa 1.5 ampere. Kaya ito yung ating sagot. So, the first two can be calculated using VIR because the voltage and resistance is given. The current through E1 can be calculated with the help of Kirchhoff's junction rule that states whatever current flows into the junction must flow out. So, I1 and I2 are added together. Sana po malinaw yung ating concept pagdating sa Kirchhoff's junction rule. So, the current entering is equal sa current leaving. Ayan. Recap lang ulit natin yung ating naging lesson for today, which is yung ating Kirchhoff's law. So again, it was named after Gustav Robert Kirchhoff rather. So again, this is just to sum up or generalize yung naging natutunan nyo for this discussion. Again, this Kirchhoff's law was named after Gustav Robert Kirchhoff. And pinapakita dito yung law of conservation ng charges and yung ating energy. So dito po sa Kirchhoff's law, meron tayong dalawang rule na sinusunod. Una is yung ating junction rule or yung KCL, and we have the KVL, right? So pag Kirchhoff's junction rule, doon tayo nagpe-pertain sa current entering is equal sa current leaving. And kapag sa ating loop rule naman, we're pertaining to the summation ng mga voltages na madadaanan ng ating loop, and that is equal to 0. And here, papansinin nyo, these are the steps for the Kirchhoff's law para ma-analyze natin yung ating circuit problem. Una is to label all the current, choose any direction. So, we're the one have the will kung ano nga ba yung direction ng ating mga currents. So, ito, I1 dito siya papunta, I2 dito papunta, yung I3 natin daw dito pataas, I4 natin dito pataas, and syempre dito may current pa rin dito which is flowing like this. So, write down natin yung ating junction equation. Diba? Alam natin that the junction, ito yung connection sa mga branches natin. So, the current in is equal sa current out. So, yun yung magkakaroon tayo ng equation na ganun ha. And then, after, the third step is to choose loop and direction, your choice. So, ito yung ating looping na ginawa. Then, write down natin yung mga voltage changes, follow the loops. So, solve the equation by substitution or combination para mahanap natin yung ating unknown value or yung pinapadetermine sa atin ng problem. So, ECE2A, this is set as your an activity for today. So, in this circuit below, you are given E1, E2, R1, and R3, and R2, and R3. So, pinapanap sa atin yung ating I1, I2, and I3. So, dito na po natatapos yung ating discussion. Sana ay may natutunan po kayo. God bless. Bye-bye.